I want to draw by hand the solid region's volume is given by the following double integral, then find the volume of the solid. So I need to figure out what this looks like and draw it by hand. Doing these graphs by hand is probably one of the toughest things that you'll be doing. It's not easy to do. So obviously this is a three-dimensional something. So I know I'm working in 3 space. So I'm going to start off in 3 space. And I'm just going to think analytically about this. Okay, if I'm at the origin, what's the value of this function? Well, x is 0, y is 0, so I'm going to be here at, say, 4. Now notice I need to deal with x from -1 to 1. So I'm going to bring this out and say -1 is right here, which would put +1 about there. And what I'm thinking is what's the value of this function when y is 0 and x is -1? Well, that's -1 squared, which is 1. 4 minus 1 is 3. So in this direction, I'm going to come down to here. And same thing here, I'm going to come down to about here, where this is at 3. Trying to draw 3 space on a 2-dimensional surface, I get it, it's not easy to do. So I get this parabolic sort of an action here. This looks like 4 minus x squared when y is 0, because it really is. Now I'm going to go the other way. I'm going to think about this. Y goes from 0 to 1. So when x is 0, I'm on the y-axis now. What do I have here? Well, that's a 3. So this 3, this function here is going to come down to 3, which again is kind of tough to draw. So 3 would be about here. So I'm going to get it going down like that. Because you know what? Going in this direction is also parabolic. If I were to continue this out here where y went to -1, this would be a parabola going down. Just like this is parabolic, this is also parabolic. Now, I'm going to bring this out because I'm actually over this boxed area. And if I just think of the corners, this one y is 1, x is -1. When I get those values in there, this is 4 minus 2, which is 2. So over here, it drops down to where 2 would be, over this point. And likewise, over this point, it would drop down to where 2 is going to be. So it's also become kind of parabolic like this. And that's kind of sort of what this thing is going to look like. And I didn't do the best job drawing it. That should actually go there. Sorry about that. Let me see if I can clean that up just a teeny bit. That's a little bit better. But basically what I've got is this object that is parabolic in this direction and parabolic in this direction. And it's sitting over this box in the xy plane. So that's really what I'm dealing with. Okay, cool. Now that I have that, let's go ahead and find the volume between, remember what we're talking about here. We're talking about the volume between this surface and the xy plane over this particular region. And here's my region of the xy plane. Okay, so like normal, I'm going to grab this piece and integrate that as a separate problem. So I'm going to take the integral from -1 to 1 of 4 minus x squared minus y squared dx, which is going to be 4x minus x cubed over 3 minus y squared x from -1 to 1, which would be, see, 4 minus 1/3 minus y squared minus a -4. The -1 cubes -1. I have a double negative, so that's going to be plus 1/3. And x is -1. There's a double negative, so it's going to be plus y squared. Now, if I move this negative in, this would be a positive, this would be a negative, and this would be a negative, so I can drop the parens. And I am going to end up with, see, 4, that's plus 4, I'm going to have 8. And this is going to be minus 2/3. And this is going to be minus 2y squared. So now I need to integrate this with respect to y with that outside integral. So I will integrate from 0 to 1 of 8 minus 2/3 minus 2y squared dy. And of course you're probably thinking, why didn't I combine these? Well, you know what? Probably should have. This is going to be 24 minus 2, which is 22 over 3. So let's just go ahead and make that 22 over 3. dy. So this is going to be 22y over 3 minus 2y cubed over 3, evaluate from 0 to 1. There's y's in both, so when I evaluate at 0, it's just going to be 0. So this is actually going to be 22 over 3 minus 2 over 3, which gives me 20 over 3 as my solution.